Good afternoon, guys.
Is it not available?
Guys, can you hear me? Hello.
Yes, ma'am.
Okay, sorry for delay. So regarding your practical, we can complete your practical after your meets also, as we have not completed our syllabus. So I want to discuss regarding theory only. Okay. So you can see here in evaluation hypothesis. So you can see here in your second unit, the third part is evaluation hypothesis. We have seen the motivation. Okay. We have completed estimation hypothesis accuracy. The next topic is basics of sampling theory. So before going to discuss about basics of sampling theory, we have discussed about the estimation hypothesis accuracy. So this is related to two things, that is sample error and true error. Okay. One second. me 5 minutes, guys. So actually I'm having some net issue. So here we have discussed this. So how to estimate the hypothesis accuracy? So we have seen different types of questions related to this. Okay, and here it is based upon two things, that is sample error and true error. Can you see the slides? Guys, can you see the slides? Guys, can you hear me? Hello.
Yes, ma'am.
Okay. So here, estimating of hypothesis accuracy depends upon two things. One is sample error and another one is true error. Okay. So I have discussed about sample error and true error here. So sample error is nothing but the error which is associated with sample. Okay. So in the morning I have told you, if you are having 60 students in a class, okay, if you are having 60 students in a class, from that I have taken only 30 students as a sample. Okay, and I have got some hypothesis here, and it is performing 95%. Only 5% I am getting as error. So this is called as sample error. Okay, whatever the error which I am getting on a particular representative sample, that is sample error. Okay, and the remaining data, or the remaining students, 30 students, I am performing the hypothesis which I have got with sample error. I am performing that hypothesis, I am executing that model with other 30 students, and the hypothesis is giving 95% accuracy and 5% error. So this is called as true error. So this is the difference between sample error and true error. The error which is associated with larger data and the model is to predict for the unseen data, it is called as true error. Okay. So here you can see the formula. Error S of H is equivalent to 1 by n. That is nothing but, it means number of samples. N, you can see here, this is number of samples. F of x is nothing but target function. Okay, and h of x is nothing but hypothesis. So here f of x of h of x is nothing but it is average of differences in the output. Okay, so it means there is some error here. So if you see here, f of x is not equal to h of x, then it is 1. If you are getting the particular target function is not equal to the output value, it is defined with 1. If target function equals to output value, then it is 0. Okay, target value manaki data set lo yes అని ఉంది, output లో మనకి no అని వచ్చింది. So that is nothing but we are getting the output as 1. That means target value is not equal to the predicted value. Okay, so both are not equal. Then it is defined as 1. If both are equal, then it is defined as 0. So here, if we are getting 1, it means that there is some error. Okay, so the learned target function f of x, the learned target function f of x is not equal to predicted value, that is h of x. It is not equal to h of x, then it is error. We are having some error. Then it is denoted as 1. If f of x equals to h of x, that means that it is denoted as 0. That means there is no error. Okay, if you see here in formula, error is defined. So I'll clear everything. So what is happening in this formula? Error is defined as it is equivalent to average of all training examples, errors when x of x is belong to sample data points. So this is the formula by which we will be finding the sample error. So this is called as sample error. In the same way, we are having true error here. Okay, so here take some unseen data point from the large data which is given as new instance to the machine learning model. To predict the target level, we will be finding true error here. If it is misclassifying that, then that is called as error. Unseen data is classifying, unseen data is given, and the model is predicting as misclassification to that particular hypothesis, then that is called as true error. Example, if you are having 20 new data, okay, out of which 15 are correct and 5 are wrong. So here we are getting 75% accuracy and 25% error. Okay, so if you see here in the formula, if probability of H is more, that is misclassification is true, true error will be high. If probability of the particular hypothesis is more, that is nothing but misclassification is true error, then the true error will be high. Probability ఎక్కువ ఉంటే క్లాసిఫికేషన్ మిస్క్లాసిఫికేషన్ కూడా ఎక్కువ ఉంటుంది, ట్రూ ఎర్రర్ మిస్క్లాసిఫికేషన్ కూడా ఎక్కువ ఉంటుంది. ఒకవేళ ప్రాబబిలిటీ తక్కువ ఉంటే misclassifying the true error is less. So by using this formula, we will be calculating the true error for unseen data. For known data, we will be using sample error. For unseen data, we will be using true error. Okay. So here, sample error and true error. What we usually wish to know is the true error. That is error D of H of the hypothesis. Man true error kanukovali. Edaina data set ki. Okay. Of the hypothesis, because this is the error we can expect when applying the hypothesis to future examples. Then there only we can know our hypothesis is working accurate or not. Okay. All we can measure, however, is the sample error of the hypothesis for the data sample years that we have happen to have in hand. మన చేతిలో ఉన్న వాటికి ఎట్లాగో sample error తెలిసిందే. కానీ మనం కనుక్కోవాల్సింది ఏంటిది? True error. Okay. So the main question is how good an estimate of error DH ante idi true error is provided by the error S. Ante sample toti hypothesis enta accurate ga work అవుతుంది అనేది మనకి true error తోటి తెలుస్తుంది. We can estimate with that. Okay. So this is about sample error and true error. Now for all these we need to know about the basics of sampling theory. Okay. In sampling theory we come across error estimation, estimating the binomial proportions, what is binomial distribution, what is mean, what is variance, what are different estimators we are using, what is bias, what is variance, what is the confidence interval we have to use, what is two-sided and one-sided bounds. So all these things. Okay. So our objective is to reduce the true error here. That matches with sample error. That means we have to develop machine learning model which is highly generalizable. So which will work well with training data. That should work with unseen data. Okay. So here, whatever the output which we are getting, that should be generalizable with the unseen training examples. So if you see on training examples, if sample error is 5%, and for true error with unseen data also, it will be around 5%. There should not be much difference. When we are getting nearer error to sample error and true error, that means our mathematical model is predicting accurate result. There should not be much difference in between sample error and true error. Okay. So in this case, our machine learning model is highly generalizable and it is performing good accurate. Then we can say our model is giving us best result, accurate result. Okay. So how to summarize the results of machine learning model? Because here machine learning models gives lots of details like R square measure, okay, F statistics, okay, standard deviation, coefficients, T critical value, Z value. So how to interpret them? So these all measures we will be using with our mathematical model. So these are all nothing but sampling theory. These are all basics of statistics. Okay. So how to interpret them? So these are the different measures. These measures are greater than particular threshold. So I will select particular machine learning model. So with this, what I'll do, I'll select one particular machine learning model with this particular sample or statistic formula. With the help of data set, I'll be using one algorithm. With that algorithm, I'll be using these different types of statistical methods to get the result. Okay. So to take the correct decision to how to select a particular machine learning model, how to select a particular measure in between different best performing model, we have to understand these terms. Okay, so why we use these terms? How we say a particular machine learning model is performing very well with sample data, with which we are having in our hand. Okay, so these are all basics of sampling theory which are related to statistical inference. So here you can see these are the different sampling theory basic things we will be using with machine learning model. Okay, so what is the first one? The first one is random variable. So what is random variable? A random variable can be viewed as the same of an experiment with a probabilistic outcome. Its value is the outcome of the experiment. Example, tossing coin. Okay, so what is probable outcomes here for this? We will be getting either head or tails. So what it is, that is nothing but probability of getting outcome that is equal to head, that will be 0.5, that is 50% ఛాన్స్. ఒకసారి టాస్ చేస్తే అది హెడ్స్ అని రావచ్చు, లేకపోతే probability of x is equal to tail, that will be 0.5. So here before tossing coin we can't guess, but after that only we can know if we will get heads or tails. Okay, so can you guess what is the outcome of toss here? No. So that is why it is called as random variable. Here you can see whatever the x which we are using, that is random variable. So for another name for random variable is stochastic variable. Stochastic variable. Okay, so when we can't guess the output is random, probability is associated with output, so these are all called as random variables. So in the same way, one more example, that is rolling dice. So what are the possibility of getting the dice? That is 6 possible outputs. So what are the 6 possible outputs we are having? Either 1 or 2 or 3 or 4 or 5 or 6. That is nothing but probability of getting x is equal to 1. That will be 1 by 6. So likewise, probability of getting x is equal to 6, that is equal to 1 by 6. So these are all nothing but random variables. We don't know the output. When we get the output, then only we can know. Okay, so at these places we will be using random variable to predict the output by using probability. And here one more example, that is heights of student. Okay, so if you take the example of heights of students, it is called as deterministic variable. Why? Because I can measure the student height. Okay, that's why it is called as deterministic variable. Deterministic variable. These are different statistical words which we will be using. Okay, and if you take one more example, that is date of birth. Okay, and I asked to calculate the age gain on a particular year. Okay, so what is that? Date of birth is 1995. Okay, now it is 2021, so it is 26. Easily I can calculate, so that is 100% confidence. So it is also called as deterministic variable, so where I can easily give the confidence, give the result as 100%, that is called as this deterministic variable. Okay, so this is about random variable and deterministic variable. So the next one is probability distribution. So what is probability distribution? Probability distribution for a random variable y specifies the probability. Here is nothing but probability of y is equal to yi, that y will take on the value yi for each possible value yi. So same, if you take uh, coin toss, coin toss. So I am performing experiment here, that is y. Okay, now random variable is y here. Either probability of y is equal to yi. This is the probability distribution. Okay, that is y is equal to h or y is equal to t. So this is the probability which we will get when I toss the coin. Okay, so here yi is nothing but it is set of values, set of output values, that is heads or tails. Okay, so now consider this is one thing. Now consider performing two coin tosses. You are doing experiment by using two coin toss. So two times tossing the coin. Okay, so what are the possible outcomes you will get? So what are the possible outcomes you will get? That is h. Two times I'll get heads, t, either heads or tails, or th. So this is the outcome which I'll get. Okay, that is nothing but four possible outcomes. Now probability distribution can be taken as table. Okay, so I'll show you the table here. So here, what is my question? Probability distribution can be taken as table with number of heads, that is number of heads. Okay, and what is the probability that I have to see here? Number of heads, that is 0, that I'll get it as 0.25. That means how many outcomes I'm having? 2 heads, 1, 2 tails, 1 tail, 1 head, and 1 head, 1 tail. So this is my outcome, 4 possible outcomes I'll get. So from this, number of heads is 0. Okay, if you see here I'm having heads, this is not possible. If you see in this also, yeah, I'm having heads, in this also I'm having heads. So these three are not possible. So I'll get only one, that is tt, that is equal to 1 by 4. 0.25 is equal to 1 by 4. That is one probability of getting 0. 0 probability of not having no heads, number of heads. That is equal to 1 by 4. Okay, so 2. చేసినప్పుడు ఒకటే హెడ్ రావాలి. అది ఏ కాంబినేషన్ లో ఉంది? టీహెచ్ అవుట్ 2 5. వన్ బై 4. సో ఒక్కసారి వస్తుంది అన్ని పాసిబిలిటీస్లలో. ఓకే, సో దట్ ఈస్ 1 by 4. The chance is 0.25. So this is called as probability distribution of random variable. Okay, so probability distribution of number of heads. So what we are doing here, we are finding the probability distribution of number of